All
to
right. So
complete.
no doubts at all?
Yeah. No, now, but I've checked my notebook, the school one. I have some missed work there, so I have to complete that.
All right. No worries. So let's wait for a few minutes. All right. Then we can start the
Right.
class.
All right.
Hello, Kinza.
Hello, sir.
Everything good?
Yes, sir.
Complete the assignments?
No, sir, not today's.
All right. Why not?
Just got a bit more. The schedule was busy, that's why. I'll do it today itself.
All right. All right. So by next class, NCERT and assignments would be complete. All right.
Yes, sure.
All right. So I hope you revised what we did in the last class, right?
Yes, sir.
Second order derivative and limits. I introduced you to limits. We did direct substitution and factorization, right? So let me give you one question on factorization so that the revision will be complete. Limit extending to 2 x cube minus 3x square plus 4 upon x to the power 4 minus 8x square plus 16. All right. Please try to evaluate this. You guys know how to factorize cubic polynomial, right? Yes or no? Sahel, Kinza?
Once we did
Yes,
it.
sir.
Sorry, I did not get any of you. What did you say?
Yes.
Yes. All right. Okay, then try to solve this. No issue, Zaid. Right, this is the question we are solving today. First question of this class. Try to evaluate this. Zaid, I think we did this in the trial class, right?
Yes, sir.
All right, no worries. Kinza, Sahel, have you solved this?
Not yet.
Not yet. Are you able to factorize this?
Yes, sir. Yes, sir.
All right, Sahel.
No, sir. Would you show it to me?
All right. See, very simple. First method is direct substitution. So after you put x equals to 2 here, 2 to the power 3 is 8 plus 4 is 12. 2 to the power 2 is 4 into 3 minus 12. So 12 minus 12 is 0. So we know that x minus 2 is a factor of this numerator. Yes or no, Sahel?
I'm not sure, sir. How do we get to know that?
See, by putting x equals to 2, we get this becomes 0.
Okay, so bringing 2 on the left hand
Yes.
side.
So x minus 2 will be a factor of this.
Okay.
So now we can divide this whole numerator.
Long division.
Yes. This is the only way to solve cubic polynomial questions. By
Okay,
factorizing.
so
Yes.
we don't have to use the right hand limit or left hand limit or something like that.
No. Here factorization. All right.
Okay.
Yes,
Okay.
factorization. So we are trying to cancel
Is
out
this
the
there
factors.
in the NCRT? No, like, is this there in the NCRT or this is separate?
This is class 11 topic, sir.
Oh, 11th. Okay, okay. That's
All right, because we are going to need this in the coming thing. All right.
good. Okay. Got it.
So how to factorize this? By doing long division. This is the only way to factorize cubic polynomials. Find a factor, divide, get the other factor. All right. So you know how to divide this, Sahel?
Yeah, sir.
All right. So
On
please
the
tell me.
question will be x square. Yeah. Then we have to multiply it with x cubed down there.
Do the calculation. Tell me what answer you get. All right.
Yeah. Okay. I'll do this.
Let me solve this. No worries. So this is x square. So we get x cube minus 2x square. This is minus. This is plus. So we get minus x square plus 4. Now we have to multiply with minus x. So minus x square plus 2x. So this is plus, this is minus. So we get minus 2x plus 4. Now we have to multiply with minus 2 to get minus 2x plus 4. So this is 0. So what factor we got here? We can write this numerator as x minus 2 into x square minus x minus 2. Right. Now I can write this as x square whole square minus 2 into 4 into x square plus 4 square. Yes or no? All of you?
Yes.
Right. Sahel, Kenza, this is clear?
Yes, sir.
Yes, sir.
So this is limit x tending to 2. We can again factorize this thing. So x minus 2. So the x square minus 2x plus x minus 2. Now this is, suppose this is a and this is b. So this is a square minus 2ab plus b square. So this is a minus b whole square. I can write x square minus 4 whole square. This thing is clear?
Yes, sir.
Right. So limit x tending to 2, x minus 2, taking x common here, x minus 2 plus 1 common here, x minus 2. This is again, I can write x minus 2, x plus 2 whole square. So limit x tending to 2, x minus 2, taking x minus 2 common again, x plus 1. This is x minus 2 whole square, x plus 2 whole square. So x minus 2, x minus 2, x minus 2 whole square is cancelled out. Now use direct substitution because we have cancelled the factor which was making the denominator 0. So putting x equals to 2 here, 2 plus 1 is 3, 2 plus 2 is 4 square is 16. So the final answer is 3 upon 16. This thing is clear?
Yes, sir.
All right, Sahel.
Yeah, so clear. I'll just note it down.
All right, note it down. I'll give it 2 minutes.
Done, sir.
Done, sir.
Okay. So this is factoration method to solve limits. All right. The first method we learned is direct substitution. Then it is factoration. The third method is rationalization. All right. So what is rationalization? We have been doing this all your life. Root 2 plus root 3. If somebody asks you to rationalize, what you do? You multiply and divide by changing the sign. Right?
Yes, sir.
All right.
Yes,
Help
sir.
in the. So this numerator becomes root 2 minus root 3 upon this is 2 minus 3. So root 2 minus root 3 upon minus 1. So root 3 minus root 2. This is called rationalization. This method is used a lot when solving questions of limits. Let me give you a simple question. See if you can solve this. Limit x tending to 0, 2 plus x under root minus root 2 upon x. All right. So you get the idea what to multiply and what to divide, right?
Yes.
All right. Try to solve this. No, Sahil, you can multiply and divide by the numerator also. Right. Root 2 plus x minus root 2 upon x. Multiply by this, divide by this. All right.
But then we'll have root on the denominator, right?
That is not an issue. All right. Because when you put x equals to 0, this will be root 2 plus root 2. This is not becoming 0.
Okay,
X
got it.
making it 0. Right.
Got it.
Try to do this. Simplify this. Inza, you got the answer?
Just doing it, sir.
All right.
Sir, can you do it?
All right. So this is limit extending to 0. The denominator is same. In the numerator we have 2 plus x minus 2, this square minus this square.
Yes,
Right.
sir.
So limit extending to 0, minus 2 plus 2 is cancelled. This x and x we can cancel. So 1 upon 2 plus x upon root 2. Now we can try direct substitution. So x equals to 0. So 1 upon root 2 plus root 2, 1 upon 2 root 2.
Yes, sir. Okay.
Okay.
I was getting something wrong. Yeah, I got it. Thank you.
All right. No worries. Sahel, this is clear?
Yes, sir.
All right. Zad?
Yes.
All right. Please note it down if somebody has not this. Next question on this. Limit extending to 0, x upon under root a plus x minus under root a minus x. Whenever the question is of rationalization, you will get a feeling, all right, after seeing. So I think you get what you have to multiply and divide here, right? All of you?
Yes.
All right. All right, Sahel. What about rest of you? All right. Kinza, have you solved this?
Almost.
All right.
I
Try to
just
solve.
wanted to do the substitution now.
All right. Send the answer in the chat.
Yes, sir.
Hello, Iman.
No, sir.
You were not there in the last class, right? I think.
No, sir. No, sir, I wasn't.
And the class before that also.
No, also no, sir.
All right. So have you got the lecture videos?
No, sir.
All right. Please get that. All right. Otherwise,
Okay, sir. I
the
will.
chapter. Yeah, because we completed that differentiation part. All right.
Okay, sir.
So what we can do here? Limit x tending to 0, x under root a plus x minus under root a minus x into under root a plus x plus under root a minus x whole divided by under root a plus x plus under root a plus. Right, everyone?
Yes.
Yes, sir.
So limit x tending to 0, x under root a plus x plus under root a minus x brackets. This is a plus x minus a minus x. So we can see here that this is limit x tending to 0, x under root a plus x plus under root a minus x. A and a will be cancelled and we'll have 2x here. So this is cancelled. Put x equals to 0. So root 2a plus root 2a, 2 root 2a, 2 and 2 will be cancelled. Root a is the answer. Sahel, how did you get 2 root a?
I made a mistake, sir. I checked again. It's root A.
All right. Kinza, you solve this?
Yes, sir. But I didn't get the correct answer.
All right. You also made a mistake.
Yes, sir.
These are very simple questions.
One doubt.
If you have a doubt?
Yeah.
All right.
Like in the bracket, x would the x get cancelled, right? Because they are 0. So root A plus root A will be 2 root A, right?
Yes.
So the answer
But
will be 2 root. Okay.
there is a 2 here also, right? In the denominator. So 2 and 2 will be cancelled.
Okay, you didn't show it. Okay, correct. I forgot.
Because see, you want me to, then I can write the step also.
No. It's fine. It's fine.
All right. Yeah.
Even I did without steps. That's the reason I made a mistake.
Yes, so, but I did a lot of practice by writing steps in my childhood, right?
Right, sir.
Never skip steps. And don't make like silly mistakes in this type of questions. Very simple questions. All right. Eman, this is called rationalization of solving limits. All right. This is class 11 topic, but we are revising it for the continuity part. All right.
Okay, sir.
All right. So you also try this next question. Limit x tending to 0, under root a square plus x square minus under root a square minus x square whole divided by x square. All right, very simple. I do not want anyone to make any mistake. Do it very calmly. All right. Kinza, Sahel, especially you guys.
Sir. Got it, sir.
All right. What is the answer here?
1 by root A.
1 by root A. All right. Everyone got the answer? All right, Zad. Sahel, what about you?
Got the answer, sir. Got it.
All right.
Yeah.
All right. Aman, did you try this?
I couldn't get the answer. So.
All right. Let me solve it. This limit extending to 0. A square plus x square minus a square minus x square upon x square multiplied by this a square plus x square plus a square minus x square whole divided by a square plus x square plus a square minus x square. All right. So now this denominator will remain same. All right. Let me just call it a. So I will not be wasting too much time. So this square minus this, so limit extending to 0, a square plus x square minus a square minus x square will divide by this a. So limit extending to 0, this is a square plus x square minus a square minus x square plus x square. So a square and x square is cancelled. This is a. So in the numerator we have 2x square. In the denominator we have x square into this quantity, a square plus x square plus a square minus x square. So this is cancelled. Put x equals to 0. So this is under root a square. So a plus under root a square. So a 2a. So 1 upon a. Right? 1 upon root a said Kenza. Did you say 1 upon root a?
Yes, sir.
The answer is 1 upon a, right?
Yes, sir.
So again, like you missed the square, and everyone agreed with the answer. So I think everyone got the wrong answer. Zayed, Sahel.
So I got like 1 by root a whole square. I didn't make it 1 by a.
Yes, so 1 by root a whole square is 1 by a. All right.
Yeah, right, sir.
So I hope the methods are clear, right? Mistakes
Right.
we cannot
Steps
do
are
a
clear.
lot. All the steps are clear. So these are the
Yes.
3 steps to evaluate limits question. First is direct substitution, factoration, then rationalization. Always move with this order. Do not try to change the order. Next is standard limits. All right. These are some standard formulas that you can use in many questions. Limit x tending to a, x raised to the power n minus a raised to the power n upon x minus a. If you put directly x equals to a here, a raised to the power n minus a raised to the power n is 0, a minus a is 0. So 0 by 0 we do not like. So what is the direct formula here? N a raised to the power n minus 1. All right. Whenever you see this kind of limit, you can use it directly. This formula. For an example, limit extending to 3, x raised to the power 5 minus 3 raised to the power 5 upon x minus 3. We cannot factorize this yet. You will have to use long division, etc., etc. But better to use this formula. This is the same pattern, x raised to the power 5 minus 3 raised to the power 5, x tending to 3. So we can directly write this is n. So power into the value, the number, into power minus 1, 4. So 5 into 3 raised to the power 4. What is 3 raised to the power 4? 81. All right. So 405 is the answer. This thing is clear,
Yes.
everyone?
Yes, sir.
All right. Aman, this is clear.
Yes, sir. I think.
All right. Let's solve few questions. Note it down. Then I'll give you a few questions. Try to solve this one. All right, there. Anyone solve this? All right, Sahel, Aman, Kinza. Are you able to solve this?
No, sir.
All right. So limit x tending to 2. This is x raised to the power 10 minus. If you write the factors of 2, like 1024, in the form of 2, this will be 512, 256, 128, and so on. You will get 2 raised to the power 10. All right, you can trust me on this. Keep doing the factors. You will get 10 factors of 2 x minus 2. Compare this to the standard formula x minus a power is same and divided by the same numbers and x tending to 2. So you can apply this formula directly. So this will be 10 into 2 raised to the power 10 minus 1. 10 into 2 raised to the power 10 minus 1 is 2 raised to the power 9. All right, and 2 raised to the power 9 is 512. So 5120 is the answer. All right,
Yes, sir.
everyone is clear? Aman?
Yes, sir. Clear now.
All right. Next question on this. So whenever you need or see this type of thing, divide by the same number. Sometimes questions like those come. Let me give an example. Limit x tending to 2, x raised to the power 10 minus 1024 upon x raised to the power 5 minus 32. All right. So what we can do here, see this question and this question is almost same, but instead of x minus 2 in the denominator, we have x to the power 5 minus 32. So what we can do to apply that formula, we can write this is 2 raised to the power 10 upon, we can divide by x minus 2, all right, and multiply x minus 2. And this is x raised to the power 5 minus 2 raised to the power 5 divided by x minus 2 and multiply by x minus 2. Why so? Because we know this formula is applicable to this. The formula is applicable to this. And this is getting cancelled. Am I clear on this? What I said?
Yes.
So can you explain again? Like, couldn't we have write x raised in the denominator, x raised to 5 minus 2 raised to 5 or something like that?
Sorry, I did not get what you asked. Sahel?
So couldn't we have written like x raised to 5 minus 2 raised to 5 or something like that?
Right, we wrote this, right? We converted this to this only, x to the power 5 minus 2 to the power 5.
Okay.
But look at the formula, x raised to the power n minus 2 raised to the power n upon x minus 2, right? But there is no upon x
Oh,
minus
so
2.
this is another formula.
No, the same formula. X raised to the power n minus a raised to the power n. I just told you the formula. This one. To apply this formula, you need x minus also, right? In the denominator.
Right.
Like in this question, but you do not have that in this question. To apply this formula, you must have x minus 2 also, right? Cell.
Right, sir.
So what I did, I divided x minus 2 in the numerator and in the denominator to make this formula. Now look at this as two questions. One is this formula, one is this formula. All right. So one formula for numerator, one formula for denominator, will get the answer. Am I clear now?
Yes.
Got it.
All right. So please solve it. Send me the answer. All right, Sahel. All right. Aiman, have you solved this?
Yes, sir.
What is the answer?
64.
Absolutely right. So this we can directly write. This is 10 into 2 raised to the power 9 upon 5 into 2 raised to the power 4. So this is 2 and this is 2 raised to the power 5. So 2 raised to the power 6 is 64. All right. So I believe everyone is clear about this now.
Yes.
Yes,
Some
sir.
more formulas. All right. Limit extending to 0 sine theta. What is the value of sine 0? Who can tell me? What is sine 0? Sine 0? Open.
0.
0. Absolutely right. Z, that is not 1. This is 0. And what is cos 0?
1.
1. Right. So these two you already know. Limit extending to 0 sine theta upon cos sine theta upon theta is also 1. All right. Sine theta upon theta is also 1. What this means, whatever value you have as the angle of sine, if it is divided by the same value, then the answer is 1. For an example, limit extending to 0 sine 9x upon 9x. This is also 1. This thing is clear?
Yes, sir.
So can you explain the first two?
First two, all right. Direct substitution, if you put x equals to 0, then sine 0 is 0. So sine 0 is 0. Limit x tending to 0 cos theta. So try to put, this is theta, my bad. All right. So theta we can put directly 0. So cos 0 is 1. All right.
All right.
The third one is very important. Sine theta upon theta is 1. So whatever value you write here, if I write limit x tending to 0 sine of Sahel upon Sahel, and this is Sahel tending to 0, this is also 1. Whatever angle you write here, if it is divided by the same angle, then this whole limit becomes 1, given that theta is in radians. All right, don't try this for degrees. Next is limit theta tending to 0 tan theta upon theta is also 1. All right, limit theta tending to 0 1 minus cos theta upon theta square is half. All right, note it down.
Sir, how does it make a difference, radians, degrees?
Sorry,
How does it make a difference, radians or degrees?
in degrees, because see, this, like, somebody invented this, right? What he did or she did, I do not know who invented this. They actually calculated this limit. All right, and this is true for radians, and the why a difference. All right, let me tell you. This is only true for theta is very, very small. All right, and you don't need to know, all right, Sahel, but we are already like a lot behind times, right? But if you want, then you can go back and ask for my radian and degrees videos. All right, trigonometry, first or second video, class 11th. All right, Sahel. This is clear, Sahel. Just ask the team to send you trigonometry first and second video, class 11. You'll get why the difference comes. All right.
Right, sir, got it.
Yeah, because we are already behind a lot of syllabus, right? So we have to complete this. We cannot take 10-15 minutes for this. But please do get that. If you have any doubts in class 11 topics, we have all the recorded lectures. You can get that, understand whole topics. If you still have doubts in limits, you can get the limits video and get your doubts cleared. All right. So
Right, sir.
this is also true. And remember again, whatever the angle be, does not matter. The answer will be same. If I write 1 minus cos z upon z square, given that z is in radian, this will be half. All right.
Yes.
All right. So note it down. Done, everyone?
Yes.
Yes, sir.
All right. So let's try to solve a few questions. Limit x tending to 0, sine 3x upon x. Try to solve this. All right, Sahel Zaid, correct answer. Aman, are you able to solve this? See, look at the formula sine 3x. That means here theta is 3x. So what do we need in the denominator?
3x.
3x. But we have x. So to make it 3x, we can multiply and divide by 3. Yes or no?
Yes, sir.
So this becomes 1. So 3 comes outside. Answer is 3. All right.
Yes, sir.
Very simple. Next question. Limit x tending to 0. Sine 5x upon 2x. Sahel, please check your answer again. All right. So this is limit x tending to 0 sine 5x upon 2x. Kinza, what angle we have in sine x here in sine function?
5x.
5x. So what do we need in the denominator?
5x.
So multiply by 5x. Here divide by 5x. So this thing here becomes 1. This x and x is cancelled out. So the answer will be 5 by 2. All right.
Oh, okay, sir.
Very simple. All right. Aman, this is clear? Aman, Sahel, this is clear?
Yes, sir.
Yes, sir.
All right. Next question. Limit x tending to 0. Sine ax upon sine bx. Solve this. All right. Sahel, Zaid. Kinza, Aman, have you solved this?
Doing it, sir.
All right. No, Sahel. Sine function cannot be in the denominator. All right. We are not removing the sine function. All right. As such, we are putting the value. How to explain? See, Sahel, have you ever thought how we evaluate this limit? Like what is actually happening?
By putting values, right?
Exactly. So suppose we have x square minus 4 upon x minus 2. So this factorization, right? Factorize and cancel out, then put the direct substitution. These are all tricks. What we actually do is make a table. All right. Suppose this is limit extending to 2. So what we do, first put x equals to 2.01. Find what value we get. Then 2.001. Find what value you get. 2.0001. Find what value you get. Then we make another table. Put 1.999. See what value we get. 1.9999. All right. So all of these values we calculate the whole quantities. X square minus 4 upon x minus 2. Then we reach to the point that both of these tend to the value 4. That is why we say this is the limiting value, not the exact value. In fact, you can understand this for the radian and degree questions also. This is another way of explaining that also. Put degrees values 0.1, 0.001, 0.0001. Then this sin x upon x tends towards 1. But if you put degrees, I do not think that will tend to that value. That will come near about pi by 180 something. All right.
Got it, sir.
Yes. And here also, that is why we did not make this formula out of thin air. What we did, we put different values, closest and closest to 0. Then we checked what values it tends. All right. That is why the formulas are very helpful to us. We cannot do this every time a limit arises. All right. I hope I'm making a bit sense. Right?
Yes.
This is a bit fast. All right. So limit x tending to 0. How to evaluate this? Sine ax. We want ax in the denominator. So multiply by ax and divide by ax. This is sine bx. We need bx in the denominator. So divide and multiply by bx. This becomes 1. This becomes 1. X and x is cancelled. The final answer is a upon b. Is it clear,
Yes, sir.
everyone?
Yes.
All right. I hope this is clear because we are going to need this. And this thing is also clear, right? Like what is actually happening in limits. See, let me give you an example by drawing a graph. See, what limits tell us is if there is no value at this function, at this value, like x equals to a, there is no value of the function, then what would the value be if it would exist? Like what is the neighborhood point tend towards? All right. Suppose Sahel lives in this building. There is a neighborhood here and here. All right. And I want to find out what is the net worth of Sahel or how rich he is. And I do not have access to any database of his. So what I can estimate? I can estimate the neighborhood, right? That they are millionaires. Then Sahel probably would be millionaire also, right? Yes or no?
Yes.
Yes, sir.
So this is what limit like basically is. We do not find the value at x equals to a. What we do? We go to its neighborhood. And the neighborhood is a minus h. What is h? Small positive value. Why small? Because the closer we come to Sahel or x equals to a, the better our estimation would be. So this is why this is called LH, left hand limit, because we move from this. First we put x equals to 1, x equals to 2, x equals to 3, then come closer to x equals to a. Same thing we do from this side. We put x equals to 5, x equals to 4, x equals to something 3.5. Suppose this is 3.2. We evaluate if LHL and RHL have the same value. Suppose here lives Zaid and he does not have any money. Here lives Aman, he has lot of money. So we cannot say anything about Sahel, right? Same thing is opposite also. If Zaid has a lot of money, Aman is poor, then we cannot estimate anything about Sahel. But if Zaid and Aman are equally rich, then I can say that Sahel might be that much rich. Is this thing clear?
Yes.
All right. What about rest of you?
Yes, sir.
All right. So what LHL actually is, please note it down also. LHL will be limit of that function where x tending to a minus. A minus means a minus h, where h is a very small positive quantity. We are reducing a by very small quantity. That is why a minus. We reduce things. LHL, left hand limit, right hand limit. Limit x tending to a plus. We add something to it. Right neighborhood, left neighborhood. LHL, RHL. All right. Note it down. Sahel, this is clear? Everything about limits?
Yes, sir. Clear.
All right. Note it down. few more formulas are there. Limit x tending to 0, a to the power x minus 1 upon x is log a, and if you change this to e to the power x, then this becomes 1. Then limit x tend to 0, log 1 plus x upon x is 1. This thing you also might need. Is it clear, everyone?
Yes.
All right, note it down.
So what is the third one? I can't see it properly.
This is log 1 plus x divided by x. This is 1.
Done, sir.
All right. So this is all about limits. Aman, please get the last class lectures so that you will be getting the whole picture. All right.
Okay, sir.
Yes. And in the next class, we are going to solve few questions, then jump into continuity. But please revise all of this limits thing. Complete all the assignments and NCRT. All right.
Okay, sir.
Yes, sir.
All right. Then take care, guys. See you in the next class.
Thank you, sir. Bye.
Thank you, sir.
Bye.